me up. Good day to everyone. Let's start our paper 3 revision for tomorrow exam. 可以吗? So, Celine try my very best to mention all the possible questions, okay, that will come up in the exam. So this will be the list. Example, I think this list okay, 是吗? This list should be okay, quite similar to the one that you mentioned. Okay, ma? Okay, so this is the list. By using this particular list, right, very likely is they are asking you about the temperature affect the rate of reactions. Okay, can. So let's try this particular situation. You are required to carry out an experiment to study the effect of temperature on the rate of reactions. You need to carry out the experiments using the materials and also the apparatus provided. Plan procedure 3 marks. Write down steps as many as you can. I will give you the complete step later. So before we start, right, we would like to do the real experiment. Okay, so this will be the real experiment. All the apparatus is here. Anyone come on? Who can be volunteer to do that particular situations? Anyone? Come on, you remember? Want to try? Hey, come on. Okay, Jai, come. Okay, you are the one. Start from this way. Number 1, what is the first step? The first step is actually clean this with what? What is this? This is a magnesium strip. You need to clean it with the sandpaper. So when they give it to you, they won't give you in this manner. They are going to cut in 3 centimeters. Ruler. Okay, 3 centimeters. Normally, every one of you will be given 3 centimeters. For every 3 centimeters, it will be only about 0.04 gram of magnesium. Okay, so this is the one. Now, you can see, you got this. 3. If they give you 3, it means you need to repeat the experiment 3 times. Follow? Maybe at different temperature. Okay or not? So you got 1, you got 2, and you got 3. Okay, so that's the situation. Now, the moment you get this particular situation, again, what is your first step? What is your first step? Clean magnesium ribbon by using sandpaper. So this is your first step. Okay or not? Now, after I have this particular first step already, I'll put it over here. Number 2, we need to use this thing so-called hydrochloric acid. Questions can be using hydrochloric acid. It can be using sulfuric acid. You just follow the questions. Okay or not? So that particular hydrochloric acid, it will give you about 1 mole per dm³. Be very careful after you handle with that particular acid. Make sure you wash your hand. 可以吗？可以啊。So what you need to do, you need about 150. So everyone, you need about 50. 可以吗? So number 1, we are using the beaker. This is the beaker, 100 ml, 100 cm3. So you need about 50. 可以吗? No need to you need to use a measuring cylinder in order to do. 可以吗? Okay, so pour 50 cm3. I don't have measuring cylinder. So that's the 1. A little bit too much. So I'll put it here. Okay, 50. Okay, 50. Got it about 50. Okay, cool. So the moment you have poured 50 cm3 of 1 mole per dm³ of hydrochloric acid and pour it into the beaker. Step 2. Can follow? Now, this is the step 2. After that, what happened to step 3? Number 1, you need to put it on top of the tripod stand. Bunsen burner, switch it on, start heating it up. Follow, everyone okay? All can see, so sorry, okay, for those of you online. Okay, let's see here. Hang on, Now, before you, for the first 15 minutes when you are checking the apparatus, you will get this thing so-called thermometer. Correct or not? Remember, Celine mentioned to you before, the first 15 minutes when you are checking the thermometer, what thing you need to determine? Determine the what? How many decimal point? Remember? Okay. Read for me what is the smallest scale that you have for this thermometer. Tell me the smallest scale. Smallest scale how much? So how? 1. Okay, cool. See here. So this is the smallest scale, which is 1 degree Celsius. For chemistry, what you need to do with the smallest scale to get the decimal point? Anyone remember? Divided by 2. After you divide by 2, you get how much? 0.5. Correct or not? Meaning all your reading, the decimal point, when you are writing all the procedure, when you are tabulating the table, all must use points. 1 decimal point. Do you understand what I'm talking about? 可以吗? When you're writing procedure that time, remember your temperature must up to 1 decimal point. When you are drawing table and when you are plotting the graph, you need to use a certain so-called skill. You also need to put in on 1 decimal point. Follow my talking about. Okay, yeah? Okay, so this is the one that we determine already. So after you determine, okay, now we move on to step 3. Step 3, you will need to put it on top of the Bunsen burner and you heat it up. Correct? Correct? Okay, after you heat it up, use the lower temperature first, which is when you are using this thermometer, right? Can you touch until the base of the beaker to take the reading? No, in the center. Okay, so the moment this thing touch 35, fast, put it on a white towel. Okay, ma'am? What is the function of a white towel? To see what? So that the observations can be observed easily. What kind of observations later we will show? Okay, right, Jai, here. Let's put it this way. So step number 4, you place the heated hydrochloric acid on the white towel. Okay, step number 5, Jai, right? Start doing the experiment. What you need to do, you're supposed to insert a 3 centimeter magnesium into this acid. Okay, at the same time, what you need to do, you will be given a stopwatch. Okay, now, how many type of stopwatch do we have? 2, analog and digital. So the one analog one, it looks like something behind here. Okay, can you see? Okay, in your notes, we have one thing, analog, it looks like this. Okay, can? So this is the analog one. So some of your school where you got more rich people in the school that doing the sponsorship, you are having one thing that we give them a name so-called stopwatch. Okay, digital one. Okay, so normally for this thing, it's up to 1 decimal point, analog one. Okay, if you are using a digital, it's up to 2 decimal point. Follow up. So the moment you place magnesium strip into it, you start the stopwatch. Can? Okay. Put it in, start the stopwatch. Okay, cool. See here. Now, Yihong, what is a very obvious observations you can see? What is the very obvious observations you can see? Tell me. Colorless gas bubbles is produced. Correct now. This one very obvious one. Colorless gas bubbles is produced. Okay now. Then after that, you continue to let them react. What are you doing? When shall you stop? Jai, see nicely. So this is the one. So any one of you can tell me what is actually the colorless gas bubbles. I'm using magnesium into acid. My students should know, yeah. Acid plus reactive metal produce salt, hydrogen, okay, cool. Then you got 48.1 second. Okay, so this will be the answer, 48.21 second. Follow. Now, the moment you get 48.21 second, right? So just now, I heat it until maybe 35. Okay, now, if you are given 3 magnesium strip, it's good for you to heat up to 45 and 55. Now, what is the temperature of 55? Temperature of 55 is your hand can still able to hold it. It won't be too hot. Do you understand what I'm talking about? You're still able to hold it, place it over there. And for your information, what if tomorrow you do back the experiment and see here, your reading for okay, cool. Hang on. I need to open the browsers. Wow. Oh. So we have it here. Benedict, yes. Okay, cool. Now, okay. 7 ringgit. You want exactly 7 ringgit. Okay. Now, okay, cool. That's situations. Now, I repeat. I repeat. So listen here. If tomorrow you can get something like that at 35 degrees Celsius, at 45 degrees Celsius, at 55 degrees Celsius. Okay. Now you can use this particular temperature in order to get your temperature by yourself. 可以吗? Else, if let's say the first one you get just now how much? 48 second, right? 48.21 second. Correct now? Okay, now if you get something like that, right? And if your ratio the same, meaning I am using 0.2 mole per, I am using 1 mole per dm cube of HCl, and you are also use about 3 centimeter of mg. And the first reading you get about this, the second normally is double. It's about 90. Okay, it's about wait. Okay, it's about like that. Okay, wow. Okay, so it's about like that. So if you get something about that, okay, so it will be plus minus about 90. And this one plus minus about 1.35. Why I want to give you this value? I just scared. What happens if let's say you cannot get the reading? Do you understand what I'm talking about? 可不可以? So at least you know there is a reference to you. 可不可以? So the first one is about 35. Second one is about 90. The third one is about 135 seconds. About that. 可不可以? Can follow your particular reading. But if let's say your molarity change or your thickness of your magnesium change, then they will be another answer. You all understand what am I talking about? Can follow or not? Follow. Okay, cool. Now let's run this way. Let's try on another acid. Let's say today another acid is taking, which is called sulfuric acid. Let's check whether the rate of reactions will increase. Okay, so we all play around. Hang on first. Okay. Now this is the one. Okay. Now we try on sulfuric acid. Morning. Wow. This one I don't know you all. What's your name? I said, oh, no wonder you didn't switch on your particular situation. Okay, so that's the one. Now listen to the advice. Volume of the HCl no matter because it's in excess. You no need to like measure ngam and whatever. Agak will do. Agak 50 will do. Follow what I'm talking about? And then you put it on that particular wire gauze. Hit it to 35. Next one 45. After that 55. Okay. Then after that you place back. Again, come on. Benedict here. Okay, your money is there. Okay, take it here, Benedict. Come on, do experiment. Come in front. Okay, cool, right? Jaden, here. Okay, so this is the one. Again, number one, make sure you use the sandpaper. You clean the magnesium ribbon using sandpaper. Purpose. Tell me what's the purpose of this? To remove the oxide layer. Okay, now. Okay, so same thing. Just now HCl with a sheet. This one is HCl, which one is usable. I think this one is usable. Okay, so 48.21 seconds. So now you try on this thing so-called sulfuric acid. Okay, try on this thing. So the moment you put it inside, you all can see what? Can see what? What color? Colorless what? Gas bubbles is formed. Correct. So colorless gas bubbles is formed. You just need to wait until the whole magnesium strip gone. Follow? Follow? Okay, that's the situation. Okay, cool. See, just now when using HCl, 48 point something second. This one using H2SO4, 35 point something second. Can see or not? So this particular experiment showing you that the higher the concentrations, the rate of reaction increases. But for tomorrow exam, most likely they ask you temperature. You follow what I'm talking about. So when temperature increase, your particular rate of reactions increase as well. Okay, can. Now, first experiment we do this. Now, later we will still doing the sodium thiosulfate experiment. Okay, so it's pretty fast. Okay, done already? Okay, we finish 1 set, 2 set, and 3 set. So now I want you to move on to here. See here. You are required to carry out experiment to study the effect of temperature on the rate of reactions. I will read out all the procedure one by one. You all please write down the procedure. Okay. Number one. Okay. Number one. I will say out because I need to wash my hand. Just now you all only put your didn't touch acid, didn't touch acid, right? Okay, should be okay. Like number one. Clean magnesium ribbon using a piece of sandpaper. Clean magnesium ribbon using a piece of sandpaper. Number two. Can I? Correct? Okay. Number two, look at your measuring cylinder. Your measuring cylinder, you all think how much is the smaller scale? Anyone recall? I have this measuring cylinder. Tell me how much is the smaller scale? Huh? 0.1. So you up to 0.05. No. Cannot. The measuring cylinder that you are using is actually 24610. Do you understand what I'm talking about? Okay, ma? So for all that particular measuring cylinder, your reading is up to 0.1 cm3. This is for measuring cylinder. If you are using pipette, you are using burette, their particular accuracy is up to 0.01 cm3. Do you understand what I'm talking about? Okay, ma? So step number two, what you need to do, measure 50.0 cm3. 0.0, decimal point, measure 15.0 cm3 of hydrochloric acid. By using a measuring cylinder and pour into beaker. Can? All follow? Follow, huh? Number three, heat the hydrochloric acid slowly. Heat the hydrochloric acid slowly until, depends on the temperature. What is the room temperature normally? 25, right? Can? If you want your experiment, if let's say this one, you do it by yourself, you can do it, heat it up to 30 so that you can finish your experiment faster. Okay, ma? So we can say, heat the hydrochloric acid slowly until 30.0 degrees Celsius. 等一下 Isaac, do you need paper? Anyone need paper? All got paper? All got paper? Okay, cool. So now, let's do this way. Can decimal point all mentioned, Okay, number four. Place the beaker with heated hydrochloric acid on white towel, provided that white towel is given. If it's not given, you just place it on the table. Okay, place the beaker with heated hydrochloric acid on white towel. What happens if let's say tomorrow no white towel? You just say place it on the table. 可以吗？可以啊 Okay, cool. Now number five, insert one magnesium ribbon into the heated hydrochloric acid. Insert one magnesium ribbon into hydrochloric acid and start the stopwatch immediately. And start the stopwatch immediately. Okay? Step number 6. Observe and record. Observe and record the time taken for magnesium ribbon to dissolve completely in hydrochloric acid. Observe and record the time taken for magnesium ribbon to dissolve completely in acid. Okay, last step. Repeat step 1 to step 7. At the temperature of 40.0 degrees Celsius and 50.0 degrees Celsius. Okay. Repeat step 1 to step 7. Huh? Step 1 to step 7.
Step 7 is repeat step 1 to step 6.
Oh, okay. Step 1 to step 6, sorry. Repeat step 1 to step 6 at the temperature of 40.0 degrees Celsius and 50.0 degrees Celsius. Okay. Now, if you are given 5 magnesium strip, I advise 30, 35, 40, 45, 50. 可以吗？可以啊。If they ask you to, if they want you to do 5 steps, I don't think they will ask you to do so much. The most is 3 or 4. 可不可以？可以啊。Now, construct table to record the time taken. Okay, for the completed reactions to occur at a given temperature. 3 marks over here. Can anyone, I purposely do it in these situations. Can anyone tell me how many columns is needed? How many columns is needed? 3. Okay, maybe what are them? The first one? Temperature. Okay, you can put temperature. It's a must for you to put unit. For those of you good, you want to put a T also can. Follow? Can for chemistry. What else besides temperature? Time taken. Okay, so these particular situations, it will be time taken for magnesium strip to dissolve in HCl. Okay, in hydrochloric acid. Okay, put in full. Okay, you can use the 2 columns for this. So this one, the time must be second. Anything else? Anything else? 1 over time. So these particular situations, you can do 1 over time, and then later on, you can put S negative 1 slash S negative 1. Okay. Okay, so the decimal point must be standard. Since we are using 30, it's a must for you to put 0.0, 40.0, 50.0. 可以吗？可以吗？ Can Now, for to calculate the time, depends whether you are using an analog stopwatch or using a digital stopwatch. For analog stopwatch, normally is up to 1 decimal point. For digital, is up to 2 decimal points. 可以吗？ Can review back. What happened if, let's say, the first one you did is about 40 over second? 可以吗？ If you get 40 over second, let's say this one you get 45.26, let's say second. Now the next one, how much? 90, okay, 91 or 91.75. Okay, 50?
I thought if the temperature increase, the time should decrease.
Oh, yeah. You're right. So this one will be 45. You're right. Your teacher Nyanyuk. Okay, teacher Nyanyuk. Terbalik. Thank you very much. It should be like this, okay? Because we didn't do the temperature, okay, ma? So this one is 45.21. Let's say after that, this one will be 90.37. Let's say this one will be 135.62. Let's say you do the experiment, you get this. Okay, ma? Can Now after this, calculate 1 over time. Can anyone suggest how much will be the significant number or the decimal point for 1 over time? If you are using here 1 decimal point, here 2 decimal point, how many decimal points do you think you need to give for 1 over time? 3 or 4? 可以吗? 3 or 4? Someone help me for the calculations, please. Someone help me for the calculations, please. 0.0073. Okay. 77. Okay. 737. Okay. 1, 2, 3, 4, 5. Then you put 0.074. Okay, no? Okay. Next one. Someone help me out.
0.011.
1. Okay. Next one.
0.021.
Okay. Can Let's say we use this, let's say we use this, can you all practice to draw the graph? 可以吗? I purposely use these two graphs for you. You look at behind, I got these two graph paper. One is graph 1 over time against temperature. 可以吗? Another graph is the temperature against 1 over time. Can you get these two graphs ready now? Can practice now? Okay, for those of you join online, please try it for these two graphs, yeah. Do you have the graph?
Oh.
Yes. What you want?
So is this supposed to be straight line?
No.
How smoothly the magnesium dissolve in this graph is? What do you mean how smoothly? Yeah, let me show you one more time. These two of magnesium, okay, you still got additional. See, you can take video to show. See, and take video and show your friend. Which your friend asking? Yeah, see, we have to leave. The beginning starts about lunch. You wait until the whole magnesium no more bubbles form, then you stop. Meaning no more magnesium strip.
Oh.
Easy to see, right? Quite easy to see.
So like when this.
Cannot be seen anymore. Totally inside only got magnesium chloride, and the hydrogen gas will be released to the solar. Can if you put one lighter to the speaker, you can hear pop sound. If you do it in the test tube, you can hear pop sound. Okay, easy, huh?
Most of them are very sad.
So this is no, I think the hard part is actually to heat up. That one need a little bit more time for the heating one. Can so you see dissolve no more already.
So once done.
Done. Stop the stopwatch. Follow now. Can okay.
Wait,
Against, yeah, the first graph is 1 over T against temperature. The second graph is temperature against 1 over time.
On a y-axis, what is not
Sorry?
or y-axis.
This against this, here is Y, here is X. What's your question?
When we are doing on scale, right? Do we do on scale what is not 0.0?
Yeah.
What is that for that scale? I think you do that on Apple.
No, I think it could work. I don't have this.
What do you do in the way? Yeah, it's only no, that's no.
For those of you join online, if you got problem, let me know, yeah. Ethan, so far okay for you? Hi, Abel, Yihan, Hubert, Hans, Zichong, and Jonathan. Hopefully everything good for you all. I get, oh, you get, okay, cool. Can, no problem.
Yeah.
Yeah, draw a curve line. Yes. Okay, okay. What do you mean? Okay, you don't need to start from the beginning. You understand? If you follow the graph, how is it then you think about it? For your countries.
So they're gonna make us adopt.
Okay. This is for first one. Yeah. Second one. Okay, cool. Can hang on. So think here, all and make sure you got graph one against what. You must have the title. You must have the title as well. Okay, now. So that yeah, very good. Title. Just look at your one at a time. This okay. Good graph. Continue next one. Oh, okay.
So can you
Close. Okay. Can. Oh, okay. How come your one runs? Exact. Still okay. Can. Too small. Yeah, you are right. Maybe I will increase it like double up. One, 2, 5 down, 1, 2, 3, 4, 5. Now, 4 you can double up this side. Follow on. More than 50%. At least.
70 more the bird line the
Oh, yeah. Okay lah. Yeah. Okay. How?
like 2.5. Yeah. Yeah. Okay.
For those of you try at home, yeah, if you want to show me the graph, you can send your answer to the group. Okay, I can help you to check your graph. Okay, so you are having a 2 graph. Try to play with it. For one over time, can I use 2 centimeter to 0.002? Can means 1 centimeter to 0.002. Can give it? Can. Okay, once you done, you can show me your graph. Send me a photo. Everyone here should be okay already. Waiting for you all, yeah.
No, I mean like, can you start from here?
No.
Or you?
Like picture no, it is for constantly from here. But it's not
Oh, from here to here.
0.0.
Cool, I find.
Yeah. Push it, yeah.
Very good. Title got, here got, title, graph what's against what? Graph what's against what? 可以吗 Isaac so far 做到吗 can 啊
You don't want
Okay. Hi Zoe, hi Monica. You missed something for the experiment. We are discussing this. We just finished the experiment already. Hopefully you can take out these notes and write down the informations. Okay now, this for your tomorrow exam. Okay.
This one is still curve.
It's still come. You can, no problem. You follow the questions. Because for your informations, either you get a straight line or get a curve also correct. You follow? You follow, huh? Okay, Isaac, okay, 今天笔记推动吗？可以啊，你们成功没？可以啊，成功吗？刚成功啊。OK， conductor 是 oming 还是 not oming？ 是 copper 是 oming 还是 not oming？ Look for tomorrow. Definitely. Okay. This one okay already, right? Okay, cool. So everyone okay. Let's check on the questions, yeah. Based on graph, what is the relationship between temperature and rate of reactions? Dina, give me your answer. When temperature increases, rate of a reaction increases. Okay? Can? Okay, now we move on to F. Everyone have a look, move on to F, yeah? From the graph, predict the time taken for the reactions to complete at 45 degrees Celsius. So most of your graph are something like this. Betul ke tak betul? Correct or not? Can? So you can use either one of the graph. Either 1 over T over temperature or temperature over 1 over T. They mentioned 45 degrees Celsius. Can you look for 45 degrees Celsius now? From the 45 degrees Celsius, you draw a line until you touch your particular graph and tell me this value. But is this value your answer? No, because this value is 1 over time. I want you to give me the answer of time. Can you follow? Can follow or not? 可以吗? So please do this practice and let me know. Let me know how much will be the time from your graph. You can use either graph. Okay. Much. 等一下，几多啊？
For 1 over 3 again, 0.01.
Okay, so 1 over 0.015.
Yeah, and again.
Okay, 等一下。This is 30, this is 40. Your 40 already 90. How come 45 you get less than 60? No. Just now from this particular reading, right? You can see. Okay, from this particular reading. Okay, 45. Okay, can, no problem. So anyone help me? Can you get an answer?
0.013.
You get 0.013. 0.018. Okay, cool.
0.011.
Okay, one more time, huh? You get 0.138. This is F -1, alright? I don't want 1 over T. I want you to calculate how much is the time taken to complete. What should you do? Take your 1 divided by 0.0138. And what will be your answer? Okay, cool, very good. So any answer that you all get is correct. You should get around the range of 60 to 70. 可以吗? Can? Everyone know how to do these calculations, huh? As long as you get it from the graph, then it's good. Online one, any questions? No, okay, cool. So if this is no problem, let's put it this way. So from the graph, some of you get 66. 0.00 second. Some of you get 72.26 second. All is okay. Line G. States and observations for this experiment. Dion? What do you think will be the observations for this experiment? Colorless gas bubble is released. Can? Colorless gas bubbles is released. Next, Isaac. I want the manipulated variable. What is that? Okay, temperature. Do I need symbol? Chemistry what? No need. Okay, so the manipulated you can put temperature, or the more precise one you can put temperature of hydrochloric acid. Can? Temperature of the hydrochloric acid. Now, responding variable, 寻找 time taken for magnesium strip to dissolve in hydrochloric acid. Okay, very good. Time taken for the magnesium strip to dissolve in hydrochloric acid. Constant variable, beyond. Concentrations of acid or concentrations of hydrochloric acid. Everyone good for this? Still easy, right? Okay, so if this one no problem, then you continue. Give me one hypothesis for this experiment, Zheming. Okay, the higher the temperature, or when temperature of hydrochloric acid increases, so the higher the temperature, the shorter the time taken for magnesium strip to dissolve in acid. Can. Follow Can I write my hypothesis? The higher the temperature, the higher the rate of reactions. Can or cannot? Can. So another one, you can say the higher the temperature, the higher the rate of reactions between the magnesium strips and the hydrochloric acid. Okay, can. Right, that is based on this experiment. Compare the rate of reactions at 40 degrees Celsius and 50 degrees Celsius. Right. Okay, so you got 1 mark. 50 degrees Celsius is more than 40 degrees Celsius. Explain why. Got kinetic energy. Okay, you can mention when temperature increase. The first mark you mentioned that the particles gain what? Kinetic energy. Okay, it gain kinetic energy. If let's say this one 3 marks, how? Maybe you want to give one more statement. There is one more statement. Teacher, can you send me this file with the answer in the group? The answer you need to copy down here. I can only send you the PDF file, and the answer you copy now. You can use your particular so-called handphone and snap a photo now. Okay, because I don't have the soft copy for the answer. This will be my soft copy. Can Monica? Can okay, that's the situation. Yeah. Can I send the file? Wait, maybe later I look at my smartboard, see whether I can convert my smartboard this one to my PDF file. I try. But you try to snap the copy first. Zoe, you done already? Okay, this part. Constant variable, you done already? Zoe? Can okay, so we move on to this part. You can snap the photo again. Now, the temperature in 50 degrees Celsius is more than 40 degrees Celsius. Why? When temperature increase, particle gain kinetic energy. Some more? Frequency. Now, did they ask you about collision theory? If they didn't ask you about collision theory, don't touch FOC and FODC. 1 more mark for that. Anyone having idea? Yes. Particles or reactant. Come on, Nihong. Reactant move faster and collide more often. Okay, and collide more often. Okay, so this is the one, so this is for your N. Can? Still okay? Not too hard, you really keep up the same one, you're happy. What happened if you guys say different experiment? You won't die, okay, still can do one, okay? As long as rate of reaction should be the question similar. Okay, ma'am? Now, based on this experiment, compare the rate of reactions at 35 and 55. Explain answer based on collision theory. Let's say the questions came out collision theory. How to answer, Wenze? Based on experiment, compare the rate of reactions at 35 and 55.
Rate of reaction at 55 degrees
Okay,
is higher.
higher than?
Rate of reaction at 35 degrees.
Okay, cool. So explain your answer based on collision theory. Just now they didn't mention collision theory. Now I want you to explain based on collision theory.
When temperature increases,
When temperature increases,
the kinetic energy
kinetic energy
of the particle
of particle increases. Okay, 很好。Some more?
The particles move more rapidly.
The particle
Move more rapidly.
move more rapidly or move faster and collide more often. Is it exactly the same as up?
Yeah.
Can what else? Is collision theory.
Effective collision increases.
Okay. Frequency of collisions increases and increase the frequency of effective collisions as well. 可以吗? So Celine symbol, FOC, frequency of collisions. FOEC, frequency of effective collisions. 可不可以? Can Now it can predict the rate of reactions if hydrochloric acid replaced by ethanoic acid in this experiment. Okay, rate of reaction decreases. Explain why. Line, maybe someone will try. Tina? Ethanoic acid is a weak acid.
The concentration of
That dissolve, or okay, you love ionize, that ionize partially in water to produce high or low? Low concentration of hydrogen ion. Then how come rate of reactions decreases one? Or is lesser one? So this one, less hydrogen ion. Less hydrogen ions reacts with what? Reacts with what? Magnesium straight. Therefore, rate of reactions decreases. Follow? 可以吗? 可以 Hopefully you understand my symbol, So for those of you online, hopefully, okay, Celine, tonight, this one, I'll finish my class 8. Wait until Zoom to upload is about 9 something to 10. Okay, for those of you, please, any part in front, we can watch back the recording. Okay, can Okay, line, we move on to your I. States the operational definitions for rate of reactions. Come on. Anyone want to try? Katrina, give me the operational definitions. Rate of reactions is the time taken for magnesium ribbon. Cannot put NG, must put spell out MA. Okay, for magnesium ribbon.
To react with
React.
to dissolve
Okay, time taken for magnesium ribbon to dissolve in hydrochloric acid. To dissolve in hydrochloric acid. 可以吗？ Okay, wait I don't like. I want to change a little bit.
I write rate of reaction
Ah,
is the time taken for effervescent to stop when magnesium shrimp is dissolved fully in hydrochloric acid.
yeah, I love this. Okay, hang on. Repeat one more time. My dearest Jackson. Rate of reactions is the time taken for magnesium ribbon to what?
For time taken for effervescent to stop.
For apparatus to stop.
Effervescent.
For effervescent to stop. Okay, cool. Rate of reactions is the time taken for the effervescent to stop when magnesium is dissolved in. Effervescent means the bubbles. Effervescent, this is the spelling. Effervescent.
I don't know how to
可以吗？
spell it.
可以啊？
No, I don't know how to spell it.
You don't know how to spell that? Okay, I give you my answer. Rate of reactions is the time taken for the magnesium to dissolve. Okay, or to disappear when magnesium is added into hydrochloric acid. Whatever things Jackson mentioned can. Rate of reactions is the time taken for the effervescence to stop and magnesium ribbon to disappear when magnesium is added into HCl. Follow on? Okay, yeah. So why I would like this? Because I relate with the observations. Okay, ma? Okay. Time taken for the magnesium to disappear from site. Okay, can or to dissolve completely. Now, next one. A. I think this one about it already. How come no? Okay, cool. Okay, something wrong. Okay, ionic equations. Wait, I don't want ionic equations. Do I have full equations? Give me the full equations first. If the complete equations is what? Come on.
It's effervescent.
Oh, so sorry, so stupid. Write the chemical equations. Come on, I'm waiting for this. What is the chemical equations? Come on. Mg plus KCl. What you get? Mg. 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 Cl2 plus H2. Follow up. Why? Because magnesium you are going to form Mg2 plus, Cl you will form Cl minus. Therefore, when they got married, they become MgCl2. Is these equations full mark?
No.
You need to balance it. So this will be the chemical equations. Okay. What about ionic equations? Anyone want to try? Ethan, do you think you want to try for the ionic equations? Ethan here. Oh, Ethan not here, right here. Okay, Lai, Hasi, are you here? Do you want to try for the ionic equations?
I try. So I break down the HCl. To
One more time.
become H plus. I break down the HCl. Oh, the answer is a teacher.
Okay, cool.
So Mg plus H plus.
Mg plus H plus.
2H plus. 2H plus.
Okay, you get.
You get Cl minus.
You get
Cl2 minus.
Cl minus.
Sorry, Mg. Sorry.
Okay, you get Mg.
Mg plus H2.
Mg plus.
Mg2 plus.
Yes, very good. This will be the ionic equations. Everyone know how to get these ionic equations, yeah? Because the chloride ion got no change. Before and after this Cl is minus, after that they are still Cl minus. You all follow what am I talking about? Can 可以吗，一红 ？Ionic equations can So you can see before that magnesium alone. So the oxidation number is 0. Hydrogen is +1. Chlorine is -1. Magnesium is +2. Chlorine is -1. Hydrogen is 0. So -1, no change. Does not involve in the ionic equations. You follow my talking about? Do I need further to teach? No need, can we move on to I. explain briefly, how can you repeat the whole investigations to investigate the effect of concentrations on the reaction rate? Let's say this is the rate of reactions of temperature increase, rate of reaction increase. I want to change. I want when concentrations increase, then the rate of reaction increase. How can I repeat the whole investigations?
This one is memang is from Jawaban. From picture D.
Exactly the same, no?
Okay, design around.
Packet plastic. So you just do this, no? Happy, right? You all later want to bring the acid and medicine, don't happy around. Okay, ma? Can, okay, that's the situations. Okay, okay, yeah. And basically, Katrina, basically, every year we will get this complete list 1 week before the experiment. But you only get this before your chemistry. Huh? Okay, laboratory. So everyone happy? Just study this 报告，可不可以？ Now continue. 来 and you all want to continue to discuss? 可以吗？ So have a look here. Briefly describe how can you repeat the whole investigation to investigate the effect of concentrations on reaction rate. 来, Justin, what is your answer? I want to repeat the whole investigation, but now I want to change to become concentrations. So how? Briefly describe, let's say 3 marks. What should we do?
Measure the alcohol away the
Manipulate what? What are you manipulating? Are you manipulating concentrations or what? Acid, right? How to manipulate concentrations of acid? Dilution. What is the formula?
yeah 1v1.
M1V1, M2V2. Why you want to calculate M1V1, M2V2? To calculate the amount of water needed to pour into the acid and amount of acid needed to produce repeats like you. You follow my talking about? Can? So explain this. Okay, come on, Justin. Okay, maybe you can say repeat the experiment by manipulating what? The concentrations of what? Hydrochloric acid. 可以吗？可以啊。Different concentrations of hydrochloric acid can be obtained by what is the process of adding water into the acid called what? Dilution. Using formula N1 V1 equals to N2 V2. Follow up. Still okay? Can. Now, if this is still okay, then we proceed. Briefly describe how can you repeat the whole investigations to investigate the effect of the catalyst on the reaction rate. Forgot to buy. I should get some catalyst. What is a catalyst for? Acid plus reactive metal. What's the catalyst? Anyone remember? CuSO4. How much should we put? How much should we put? Just now I'm putting magnesium into it, right? How much copper 2 sulfate should I put it in? You all think a lot or a little? A little. I am using 50 cm PuHCl. So copper 2 sulfate, I need how much you think? Can you try so much? Don't scare me. 2 to 5 cm cube is accepted. 2 to 5 cm cube is accepted. Follow my talking about? 可以吗？可以啊? So how to answer this? Yihong, briefly describe how can you repeat the investigations to investigate the effect of catalysts on the rate of reactions? Same thing, repeat the experiment by adding, what is this? How much maybe you can mention? 2 cm cube. Okay, either you like 2 or 5. I like 5. Okay, by adding 5 cm cube of what? What? Copper 2 sulfate salt lah, copper 2 sulfate solution lah, which one? Okay, cool. So 5 cm of dilute copper 2 sulfate solution into the hydrochloric acid. Can? Okay ah. Still okay ah. Okay, boleh ah. Okay, so if boleh, line, we continue the next one. Predict the rate of reactions. HCl replaced by sulfuric acid with the same concentrations and volume. We tried this just now. Jaden, what will be the rate of reaction if HCl replaced by sulfuric acid? Rate of reactions increases. Why?
Sulfuric acid more hydrogen ions and hydrogen than hydrogen peroxide.
Can you mention what is the difference between HCl and H2SO4? HCl is a what acid? H2SO4 is a what acid?
Hydrogen acid is monoprotic acid, sulfuric acid is diprotic.
很好 Increase then you can mention that sulfuric acid is a diprotic acid. Okay, which explain what is diprotic acid. Come on, Jaden. Which word? Produces what?
Produces 2 hydrogen ions.
It should be 2 mole of hydrogen ion for every mole of acid that dissociate in water. Can? Then you continue to write the same. More hydrogen ion can react with magnesium to produce salt and hydrogen. 可以吗？可以吗？ Everyone okay? Okay, now predict observations. If experiment repeated, replace magnesium ribbon with copper. Anyone? Slower. Jason say. No change. Slower or no change?
Oh, sorry, no reaction.
No reactions. And they want predict the observations. Just now, what is your observations? When I put magnesium into the acid, what you all can see? Colorless gas bubbles is produced. So now if I replace my magnesium with copper, what can you see? No gas bubbles is produced. Do you understand? Huh?
Why is that?
Why? Answer me why? Why no why no reactions? Totally no reactions. Do you all still remember the kalau nak kahwin? Jason, kalau nak kahwin mesti ada zakat besi. Yeah, electropositivity. Sebelum proses hendak cucuk. The hendak here is H plus or H2? H plus. Where is the H2? Where zakat, where condom on your zakat, you feel high. Correct? So this is hydrogen. So today we are having this thing so-called, okay, hang on, I think you all see me better. Okay. You all see me better, Okay. Now today you got magnesium plus HCl. So now hydrogen, which is here, can rampas ke magnesium, which is here, can rampas ke kasih of hydrogen or not? Can, right? So you become MgCl2 plus H2. Betul? Okay. And then later on, today I got copper. Copper plus HCl. Copper is here. Can copper rampas ke kasih of hydrogen? Cannot. Follow, So your answer is no gas bubbles is produced. And when they ask you why, tell me your answer. Why? Why?
No reaction.
No reaction at all. Correct. Why? Why no reaction?
That's reaction.
Who is less reactive? Copper is less reactive than hydrogen, but I don't like less reactive. Can I use another name? Electropositive. 可以吗? Can. So what you need to do will be over here. Let's see here. Predict the observation you mentioned. Okay. No gas bubble is formed. Why? Because your copper is less electropositive than who? Then who? Hydrogen ion, very good. Hydrogen ion. 可以吗？可以啊 Okay, like why the beaker is placed at the white towel? You. Here. Why the beaker is placed at the white towel? Come on. Come on. Hey, why are we using white towel? Come on. Hey, got white towel. Check just now. Justin, you sent to me on the list.
Okay.
Increase visibility. Okay, not bad, Gilbert. Okay, increase the visibility or so that, Dina, if this person came out tomorrow,
Jubin Putih. Jubin.
Jubin Putih is the white towel.
Yeah.
Okay, so that what? So that the time taken for magnesium ribbon to dissolve in hydrochloric acid can be seen clearly. Boleh? So that the time taken for the magnesium ribbon to dissolve in hydrochloric acid can be seen clearly. Still okay? Hannah, last question. What is the purpose of the sandpaper? To remove oxide layer on the surface of magnesium ribbon. Do you think you're enough for the revisions of tomorrow now already? I try my very best to give you all the type of questions that may be asked. 可以吗？可以啊？Can So this is the one, you all can copy down.